Welcome to another episode of Analytics Mindset. This is part of season 2. As we already discussed, we're back on track after a bit of delays here and there. But we are with linear regression with R. This video is going to be a little bit different. I'm going to go to linear regression still. We are not past that. My point on bringing you with this specific video is we want to know different tools to do the same thing. You can do linear regression in Excel, as we have seen before. In Python, we have also seen that before, and I will leave those videos here. This is a faster video in R, the programming language. Why? R is not as popular as Python, for example, or other object-oriented programming languages for software development or data analysis, but it is a very, very robust language. It allows you to do a lot of stuff, and you will see how, in my opinion, it is actually easier to do linear regression in R than in Python, and I would argue that Excel, being fully honest, and I will show you soon that. But R is a statistical software. You will need to install both R and RStudio. I will leave the link in the description so you can do that yourself if you want. And as always, I will post this code. It is just an R file. It's not very different from the Python scripts I usually put. It's gonna be in my GitHub as well. Without further ado, this is gonna be a shorter video. I will go ahead and start with this. This is RStudio. It is a GUI for R. You can use R by itself. I prefer to use RStudio because it gives you a lot of capabilities, a lot of data management, a lot of file management. I just prefer it. That's how I learned it, and I just prefer using RStudio and the tidyverse to be fully fair. But I'm sticking to base R here. Don't expect any packages. You're only gonna get base R flavor here. R, in contrast with Python, is a more statistical software kind of tool. It was created for statisticians by statisticians. Because of that, you're going to see a lot of different conventions that are not really standard in other languages, and it is still a very powerful programming language, and it's good to have in your toolkit, at least some experience with it. You can start by reading the CSV. This is a CSV that I actually downloaded from Kaggle. I will leave that link also in the description. You can go straight to the Kaggle dataset, download it, and then put it into a path, this path here. I recommend to just go to your directory, copy as path, and then you're going to change the backslash to the slashes there. You're going to need to put headers equals to true because of how the data is structured. We will go ahead, and it's very similar to Python at least I prefer to highlight this, and then you're going to run the current line of selection. You can see there that's our data. R is very powerful on reading data by default. You can see this is a data frame. I don't need to import pandas like in Python. It straight up know what it is. And I can actually get a quick glance on it. You can see here, I get a summary of every single value here in my environment without doing anything. The variable explorer tells me this is the index, this is the date, these are some of those dates, this is the open, this is the high, low, close, adjusted, close, and bold. If you're not familiar with stock data, this is the index, the US, not only US, but also some other indexes from Yahoo Finance that somebody compiled. This specific data set has the information about the date open what was the value of the index when the stock market opened, the high, the daily high of this stock, the daily low of that stock, the close when the stock market closed, what was its actual value, and the adjusted close, and sometimes it's different than the actual close. And the volume. For this, we are not going to look at anything more than the date and the close. That's all we're going to look at. We are basically saying, is there any correlation between the passage of time and the closing value of the stock index? First thing we're going to do is we are going to just get that data and get the NYA stock exchange. That is for the New York Stock Exchange. We're excluding the NASDAQ. We're excluding some international indexes there. And you can see how my observations drop from 11. Basically, I'm basically having 100,000 to 13,000. That is a lot more manageable. I really doesn't have any issues with that data, but I just do it because it makes this is a very simple out of the box linear model. I just want it to be as plain as possible, and it just helps too with reducing some more advanced stuff we have seen before. You may have multicollinearity between your variables. You may have different correlations. I just prefer to keep it to one data set because, in theory, these are just multiple data sets put together or for each index and one single variable. We are going to go ahead and you will notice in the filter data, this is more on the data preparation side, but it never hurts, that our date is not an actual date. It is a character. Why? Because it read it as yes, a character, a text, not like a date. I'm going to need to first convert it to a date. This syntax says this column is going to now be equal to the building function as date, filtered data date. I am forcing this to be converted to a filtered data. It's very similar to SQL casting, for example, or just basically getting from one data type to another type. In this case, this data is in a very recognizable format: year, month, date. R doesn't have any problems to filter that. If it was in another format, you may need to look at it. Working with dates is messy, regardless of what programming language you're looking for. Your dates should be at least somewhat standardized, and if not, you're going to need to clean them a lot. Then after that, we have the next line that is filtered data. Filtered data is going to be our next stop. We are going to filter everything before 2020 and 2013. Why? It's an arbitrary line that I draw. It makes it easy. It is 2013. It is close enough to today that you can look at it and say, oh, 12 years ago, this looked like this. But it is not as far as saying, well, this was 30 years ago. This dataset has stuff from the 80s to the 90s. It is close enough to be relatable, not as close, so we have enough data. But yeah, you could filter by any date. I just picked that arbitrarily. And you will see it drop all the way to 2000 observations, a little bit more than 2000. I reduce a lot this data set. Now, the last thing that we're going to do is get the date and close from the dataset. You could do this in the actual linear regression model. See here how, and this is for me the best thing about R. Look how simple it is. Even if you didn't know R at all, you can infer, well, this is my linear regression model. It's going to be equal to, if you ignore the subset, but this is just selecting these columns here, filter data. That is all you need to do to filter it, nothing else. But when you're feeding the model, look at how simple this is. You use the building feature function lm here, and actually if you hop over it, it's going to tell you some description of it. You say the formula, which is your independent variable. In this case, date is our independent variable, close is our dependent variable. You're saying this variable depends on these variables here. And the data is just your data, LR data. Again, I could have just picked the filtered data. I just prefer to take these two columns beforehand because it's faster, marginally faster, probably a couple of milliseconds at most. But hey, I like showing you different versions of things, different ways to work. You can see that there. Linear mod index is a linear regression model that has the formula, the close date being correlated to the date and explained by date, and the data is LR. Now, another very important thing on R is that in Excel, we will need to do either the data analysis toolpack or then use the linear est function that we already saw, or some of our other tricks like the plot function. In R, a lot of programming languages, to be fair, that's the reason why. This is very useful in the technical skill set level. You can just do this in the summary function. This gives you everything that Excel ever gave you. This is dynamic. You could run your regression model modified and you just call this and basically update this table. Python offers that through stats model, yes, but scikit-learn is more popular. Data science people, yes, don't like these summaries because they have their other preferences, etc. Last things, just for my preference, you can just say options. These remove scientific notation. As you can see here, you have all these funny scientific notations here. I'm just going to disable them from here. And there you go. Yes, a very, very quick glance at this. We can see here our residuals, our coefficients is the part I'm going to be the most concerned with. You can see here how the estimate, the standard error, t-value, and your PR. The date in the estimate on the coefficient is 1.5. What does that mean? That this exchange particularly has increased 1.5 points per day. It is a time series. Therefore, someday I will do a video on time series. There is particular considerations for time series forecasting. Just assume for now that that's a correct correlation, but that's just a side note. You have your intercept, and then you also have your significance codes. You can see how it actually the residual standard error. The multiple R square is 0.73. Being honest, that's a lot higher than I expected when I first ran this dataset. If we plotted this dataset, probably would be like something like a jiggle line, but going up. From 2019 to today, the US indexes have been going up in the long run, not in the short run, maybe, but in the long run, that has been the truth, especially from 2013. I am also omitting a good chunk of the big Great Recession, 2008, 2009 were funny times. You had 2012 with almost zero inflation and zero growth, too. All of that is excluded from this. If we included that, it would be a very different for sure. And you can see here the F statistic and the p-value. It is significant, therefore we can say with some confidence from the hypothesis testing, this is different from zero, aka there is a relationship between the date and the actual index value. But yeah, that is all for this video. It's a shorter video because of that. And as always, if you have any questions, any concerns, if you want to learn more about R, let me know. This is just more to expand your data analysis toolkit and give you a little bit more of different flavors of how you can do exactly the same thing in different tools. You should be able to be flexible to in the more professional career level. You should be able to be adaptable because the tools that you are familiar with may not be the ones that your actual job wants to do. I talk from personal experience. I am actually more trained on R than in Python, and I needed to adapt to Python because that's what my company used. And yes, that was a big change. But again, remember that you should be able to adapt yourself and apply your knowledge. A lot of these tools, a lot of these models are very applicable all over the place. You just need to be able to know, all right, do I need to use R? Do I need to use Python? Do I just need to use Excel? Maybe I can't use Excel. Do I need to even do linear regression in PowerPoint? Just to give a silly example. Those are things that you will need to think about in your job, and you just can't force everybody to use your personal tool of preference. You will need to adapt to what most people use around you. But yeah, without further ado, as always, if you have any comments, feedback, concerns, let me know. And yeah, thank you. Have a good day.